Hello, everyone, and welcome back. It's my pleasure to introduce our next speaker today. Next up, we have Ayodele Odubela, and she is the data scientist at SambaSafety. And her talk today is entitled Combating Bias in ML. So please welcome to our virtual stage, Ayodele. You can come join us with your camera and your slides.
Hello.
Hello. Okay, so I'm just going to turn my camera off and you can share your slides and take it away.
Awesome. Thank you so much. Great. Thank you so much for having me. I'm really excited to talk to you guys about bias in ML today. So getting started, a couple things we'll go over. We're really just going to define bias, talk about its impact, and then detail some of how some of the ways it really shows up in machine learning, and then going into the practitioner's role, what data scientists can do about this, and some tangible solutions to deal with it. So first, defining bias. In machine learning, we kind of think about bias in a couple ways. There's the bias variance trade-off, and then in neural networks, the activation, essentially the term we add to activation functions to avoid the multiplication by zero error. But when I talk about bias today, I'm going to be speaking more specifically about this inclination towards or against something, and the ways that it shows up in our historical data, and how machine learning really just tends to exacerbate these previous biases. So bias on an algorithmic level is really just these errors that are repeated at a large scale, but they have unfair outcomes. And the unfair outcomes is really important here. It's not just that we have skewed data, but this data with AI essentially can translate these skewed ways of thinking, a lot of times these sexist, these racist ways of thinking, into how we make decisions for things like credit scoring and who goes to jail for longer than who. So in this talk, I'm going to go a little bit further into detail about what we can actually do with that on a technical level. So this is a new kind of thinking for a lot of data scientists. So we have to have a bit of a mindset shift. We need to assume that our models will create sexist, racist, and biased outcomes unless we address them specifically. So if we think about this, when we just look at supervised learning, we are looking at tons of historical data. We have to understand this data doesn't exist in a vacuum. All of it is going to be impacted by the social, the political norms at that time, and especially depending on who's able to create the data, who's able to use it and manipulate it, and how. There's a lot of power structures here that exist in our society that we don't think about, but these historical artifacts are encapsulated in our data. So going into a couple types of biases that are popular or unfortunately common in machine learning. The first is really prejudice bias. So I think a great example of this, if you were just to create an AI to try and understand people at work, a lot of times when we're looking or we're dealing with computer vision and image data, we're unfortunately having to scrape the entire internet for as many images as we can. The problem with that is that the internet is extremely biased. Unfortunately, you would more likely get men in stereotypical male professions and women in stereotypical feminine professions. So one of the ways to deal with this is really to expose your algorithm to a more even distribution of samples. And then in addition, if you're going to roll this out to a specific industry, you want to consult with the people that the algorithm impacts. That's a step that a lot of people in ML and AI aren't doing right now. And we really need to build stronger partnerships with our product teams and our user teams to gauge how this actually impacts our users. Second up is measurement bias. So one of my biggest fears, especially in the automotive industry, is the fact that we rely so heavily on the use of essentially just cameras. The main problem with that, and I mean, I'm not saying that we don't use LiDAR and radar as well. However, a lot of the advancements in computer vision have been because of autonomous vehicles. So one of the major problems there is that there is not camera hardware on this planet that is able to capture dark skin with the same level of accuracy as it is light skin. This creates so many problems when we actually think about how these machines make decisions, how they're able to literally capture if someone is a human or not, if there is an object in the way or not. Not only that, but this has other implications as far as really fun wearable technology like the Apple Watch, but also in pulse oximeters, what hospitals use to be able to gauge a patient's blood oxygen. One of the big ways to fix this is really to broaden our pool of test subjects. So when these products are in development, typically you have a very small and very heterogeneous group of people that it's tested on. We really need to be benchmarking against these stress cases. So cases that we tend to fail more on. Unfortunately, again, when we create new hardware products, this typically isn't at the forefront of our thoughts, especially for consumer products. But when we are dealing with autonomous vehicles or any other industry that has a very high impact on a human's life, this is where we really need to kind of pick up the slack. And another really common example of bias is sample bias. So this is probably the most common in that it's very easy for researchers to just pick a random sample and assume that it's representative or not dig into how representative it actually is. That's if we even are considering the representation between our distinct classes. So sampling is one of the easiest to fix. We can stratify our samples, we can upsample. There's a lot of technical ways we can get around dealing with sample bias. And it's not just the bias in the data and that it may be skewed towards people who are more likely to respond to a survey, but really on that technical level, being able to say, hey, we looked at gender, we looked at racial disparities, and we were able to make a representative training set based off of that. So going into the practitioner's role, first thing we have to understand is that data is not neutral. Data is a snapshot of a very small sliver of someone's life. We may have hundreds of thousands or millions of rows about people, but in our feature sets, even these 200 columns of features, we only have a very small glimpse into someone's life. And a lot of the times we are dealing with data about people. When we think about it on that level, we need to understand that it's hard for us to grasp the whole person. So I work a lot in risk scoring. It's hard to determine how risky a person is with a very small amount of data. And this data is also representative of everything that was going on when it was created. I think the most powerful to understand here is how it was collected and who collected it. We have lived in a society where collecting surveillance data is normal, not prioritizing user privacy is normal. So we should understand that when we're creating machine learning models. Next is that data teams really do have power. So unlike a lot of other technical roles like in software engineering where you're really guided by product, data science teams a lot of times have a lot of power in guiding product instead, pushing the direction and pushing back on certain use cases. So that's really important, and we have to understand that it is our responsibility when we see bias in our data to have caveats, to be transparent when we're talking about the limitations of our models. Algorithmic responsibility comes in here specifically because companies tend to make these private models that the public don't have access to. However, there's very little as far as policy that requires them to be transparent about what they're doing with these models. Outside of the GDPR, there are very few legal ways for consumers to really know what companies are doing with their data. So if you want to build trust with your consumers, it's really best to just be transparent about how you're using AI in your products instead of having it be this kind of shadow technology that exists, but you don't really talk about. And this also goes into creating risk mitigation plans. We're at a place where we have an understanding that AI is going to touch every single industry. And what's difficult is that what's ethical and what's unethical doesn't always transfer from industry to industry. It's very hard to set these standards across the board. So we do need to create plans as technical folks on technical teams of what we can do when our models harm people. We have to operate under the assumption that our models will harm people and figure out what we're going to do about it. Understand what the worst case scenario is for our consumers and understand what methods they have to dispute these models. How can they report errors? How can they get more information? These are a lot of structural things that in general we need to work on and have some sort of industry standard. So going into tangible solutions, because I don't like to bring up some of these problems without talking about some of the ways to fix it. First is documentation. So this may seem really boring, but it really goes in hand with the model reproducibility aspect. We need to have better documentation for both our data and our machine learning models. For our data, I really suggest data sheets for data sets. A lot of times in industry, we're dealing with what we have available and trying to force it to be a proxy for the problem we're trying to solve. So we really need to take a step back, understand how our data was collected, how it was manipulated over time. Companies with large amounts of data typically don't do a great job at data governance. So really stepping up how we manage this data so that, you know, if you are thinking about fairness and accountability plans, 5 years down the line, if a consumer is able to come back to you and say, you know, I don't want you to use my personal data for modeling anymore, these documentation tools like data sheets will help you just understand and be able to enact some of these good data best practices down the line. And going hand in hand with that is model cards. So what you see on the right hand of the screen is Google's example model card for face detection. They also have one for object detection. And what this does, it's just a very transparent way of saying, here's our model's limitations, here are the trade-offs, here's what the performance looks like, and maybe even having a customer or public-facing way that they can test their own data. I love that Google has that, and it makes it very clear how their model makes these decisions. And then the next big piece is model explainability. So what you see are a couple different tools you can use. One of my favorites is Lime. I think we need to focus as an industry, not just on these explanations for why decisions were made, but also creating models that are more interpretable, because we expect to have more human in the loop systems than completely automated systems. I think as AI develops, we're starting to realize that these programs will be working a lot closer with humans. So having interpretable machine learning so that subject matter experts like doctors and lawyers, training them to see the output of a model as one input and then making a decision, instead of just seeing the output of a model as the end-all be-all decision that they should tell a patient or a client. And then best practices, really just testing our models with our edge cases, cases that are really uncommon in the wild, but they occur. I think one of the biggest problems in machine learning is it's very difficult to get this kind of in the wild data and to understand, you know, the demographics of every type of data our models may see in the real world, but we can attempt. So really just starting with these edge cases, and then holding our results to extreme skepticism and doing a lot more in the terms of fairness testing, understanding how we have distributed our samples over, racial and gender subsets. We need to pay more attention to these because unfortunately in the past, we really haven't. This hasn't been a end all be all for data science teams. We're still able to produce models that are sold and that are in APIs without having to do this. So unfortunately, without policy, we kind of have to just educate ourselves and figure out ways to put this into our workflows. And I think even more important than anything else listed on this slide is really consulting with the people who are going to be impacted by your models. This is one of the areas that is going to be most helpful for us to build more fair models, but very few teams actually do. And then another aspect here is human intervention. Like I mentioned, we will be working a lot closer with these AI tools than I think many expected. So getting ready to have models that are going to be working with humans, and really understanding our machine learning life cycle and how that has to change to allow for us to do these things. There have been many times in industry where I have been given a week to do a deep analysis and also have a fairly working model, even if it's not good. While these are understandable expectations, we can't say that we're really giving enough consideration to fairness and accountability if that's what our workflow is. So some key takeaways. First is that technologies weren't designed for everyone. We just have to understand that. Camera hardware was specifically tuned to make light skin look good. You may have even seen some old photos from like the 1800s of like Black mammies holding, white babies. The camera was attempting to make the child look good, not both of them. So understanding that we have to take these cultural products or cultural artifacts into consideration when we're building products. Next is really on the technical side is that we have to improve our workflows. We really have to build in understanding the impact of our models, attempting to create justice with our models, and knowing, how we are distributing some of these equitable outcomes. And then even in this last bit, autonomy, a huge part of this is that comprehension. Understanding when to use AI and when to not use AI is a huge part of creating fairness, really, with machine learning. And we should stop treating ML and AI as software engineering. If you can't read what's behind the X, it says move fast and break things. When we understand the impact of our models, we really need to know that we can't just treat it like software engineering. We can't break things when these algorithms are calculating someone's credit score or calculating if someone is going to get accepted for housing or is going to get accepted for a loan.
This is just your quick 5-minute warning.
Awesome. And last slide here really is, bias mitigation is crucial. This is the biggest piece we have to deal with. This we can check in multiple stages of the processes we already have, but having a strategic plan and having company standards for how users can report these issues. If they can do something to change their outcome. So thinking about not just bias mitigation, but really recourse. If someone gets denied for a loan, we should be able to say, hey, your credit score is at 600 and it needs to be at 650 for this loan. But if your model is going to output that someone needs to increase their salary from $80,000 to $180,000, that's not realistic. We need to think about things on a more human level and understand where we can create these paths to recourse, really. And so going back to that is honestly, the other half of Recourse is really contestability. So like I said, where consumers are able to input these errors, what kind of adverse actions are there if they're denied for something, and understanding what your company's strategy is for dealing with these disputes. Do you look into this specific model decision? Do you just see a dispute and give them reasons why they were denied for something? Coming up with these strategic plans are not going to only build trust in your company from your customers, but it really goes to building equity. So not just treating everyone fairly, but understanding how certain groups have been marginalized and adjusting for that, understanding that certain technologies will work better for some and not others is really the first step in us changing that. And we need to make fairness a part of development. So these are just three basic steps that we can implement into our workflows now. And first is discovering the unfair patterns in our data. So looking at our data distributions, understanding the whole historical context around it, noticing these unfair patterns, making them obvious and not, hey, these issues exist, but we're going to persist with this anyway. And then going into both harm mitigation strategies and methods for consumer recourse. So these are solid technical things that you can build out in your organization, both a strategy for what happens when someone is denied for a loan, what happens if they are unjustly denied for something. Coming up with these strategies are something that you and your team can do to really make less biased AI. And that's it for me. Any questions?
Okay, great. That was awesome. Thank you so much.
Thank you.
Thank you. If you could just turn off your camera for just a moment, please. And everyone, please give Ayodele a warm virtual round of applause. That was really great. I hope you all enjoyed it, and you can make your way to your next session or check out a virtual booth and have a great time.